All right, we're up and recording, so let's go ahead and get started. Obviously, I'm not here. Any homework questions should have been answered on Friday. You didn't have an assignment for today, so we'll do a couple of warm-up questions. There's our minor symbols. You got to dig for gold on your own. So I'm using a new setup today, so we'll see how it works. Anyway, here's your first warm-up question. The limit as x approaches infinity of 2x squared divided by 4 minus x squared. You kind of need to remember this. So go ahead and give this a shot for, I don't know, about a minute or two. Keep it quiet, please. All right, hopefully you know that means what's the horizontal asymptote. So you took the lead coefficients. Since the degree was the same, hopefully you took the lead coefficients, divided them, and got the correct answer of -2. Okay, so it should be 2 over -1. I don't like my new setup, but we're going to go on. Try this one. Vertical asymptotes. See if you remember about vertical asymptotes. This should actually probably say f of x. There we go. F of x equals. All right. So go ahead and give that a shot for a few minutes and see if you can figure it out. All right. Hopefully you saw that you can factor it. And hopefully you got the right answer. When you factor this, you end up with 0 in the numerator. No, I'm sorry. When you factor it, you end up with 0 in the denominator when x is 2. And so you have 4 over 0. That's a vertical asymptote. And you put -1 in, you end up with 1 over 0. That's also a vertical asymptote. So the correct answer is C. You are two vertical asymptotes. One at x equals 2 and one at x equals -1. So nice job if you got both those right. We're going to do a problem, then we'll do a brain break, and then we'll do another problem. And then you have the rest of the time to work on your homework. I'll be back tomorrow to answer any questions you might have over it. All right? But again, last week we just answered questions, did our 10 for 10. If you want, you can hand those back on the windowsill when I'm done. Okay? Moving on. Again, to optimize these problems, you've seen this 3 times. You got to read it to understand it. Diagrams and pictures help. If you're going to make those, identify the facts and the variables. That's a huge step. Figure out what's what. Is it a max? Is it a min? Are you taking the first derivative? Are you taking the second derivative? Those are key points. Also, what are the critical numbers? Are they valid? Are they actually in the problem or just solutions to the equation? Are they maxes? Are they mins? Can you use a first or second derivative test to tell? And how do they relate to the problem? And also determine the extrema and see if your answer is reasonable. That's the hardest thing. So find your equations, getting started. We'll do a couple more problems. Like I said, we'll do one big problem, brain break, and then another one. All right. Find the maximum volume of a right circular cylinder that can be inscribed in a cone of an altitude 12 centimeters and a base radius of 4. If the axis of the cylinder and cone coincide, that means they're both correct, cut down the middle. All right? That's a bad example right there. All right. Ooh, I don't know why it's not working. Interesting. Go away. It's not going away. Huh. All right. So when you try to maximize, this is what coincide means. Coincide means they have the same center. If they have the same center, that means it's symmetric. The H to the cylinder is obviously over here. The 12 is the height of the cone. The R is the radius of the cylinder. and 4 is the radius of the cone. What you should see, hopefully, is that there are some, similar triangles. That's the whole purpose of this problem. There are some similar triangles that you can use to come up with some things and hopefully answer the question. We're trying to maximize the volume of the cylinder. The equation for the cylinder is pi r squared h. That's the volume that you have to know for your next test, quiz, homework check. The other information is I said there are similar triangles. It's very tough to see them, but you have to know once you see it one time, you have to recognize it for the next time. And there's the other similar triangle I want to use. It's pretty obvious with the dimensions they give you. The 4 highlights the base of the blue triangle. The H highlights the height of the red. The 12 highlights the height of the blue. And the R, well, it's just kind of hanging out. But it represents part of the base of the red one. You can subtract it. 4 minus R, and that would be the base of the other one. Okay, so that would be 4 minus R would be the base. So now you got the base of all these triangles right here, and you got the heights. And the similar triangles is what's the key part to this. Okay, so once you set up your ratios, I did, let's see, altitude of the small to the altitude of the big, and then I did the base of the small to the base of the big. Okay, so I did altitudes and I did bases. Probably shouldn't use a capital A. Probably should just use a small a or something. Altitude or height. Okay. But anyway, that's how I set it up. You could have done big to small, or big to big, and big and small to small, or big to small and big to small. So, cross multiplying gives you your substitution. 4h, 48 minus 12r. So obviously h equals 4 minus 3r. Okay? So h equals 12 minus 3r. I'm going to use that. And what piece of information was given in the problem? Do you remember? I can't remember which example this is, but it's in your textbook. We're just talking about it. Altitude cone. Find the maximum volume of the right circular cylinder. So, I can just put that information in for the H. And now I have my equation that I can maximize. Okay? This isn't a solution substitution problem. This is just us being able to take the derivative and working this one out. Alright? So, let's get started. Substitution and the derivative, and we'll see where it leads us. Any questions? Just kidding. Moving on. Okay. So, put that equation in. And then I'll probably multiply it out, or you can just do the product rule. Makes no difference. I took the derivatives, 24 pi minus 9 pi r squared. And, once you take the derivative, set it equals 0, divide and factor, and you'll be on your way. So obviously r equals 0 is going to be an extraneous solution that has no reason for being in the problem. But the 8/3, that's kind of a interesting one. Now you just got to double check to see if it does maximize it. So you can check to see if it does maximize it. You can put it on a chart. You can take the second derivative, put 8/3 in, check the concavity. Those are all possible solutions. Do you have to check it? I mean, no, you don't, but you probably should get in the habit of checking your work. So anyway, we got the h is 8/3. If the axis coincides, it says find the maximum volume. That can be inscribed. So I got the 8/3. I took the 8/3 from this equation. I'm going to find the height and then put it into this equation. If you want, you can just take the 8/3 and you can put it in this equation and find the maximum volume. Either way you can do that. You'll probably just keep it in terms of exact value. Anyway, you get 8/3 in for the radius, 4 is the height. You put the 8/3 in right here. And simplify that. And the 3's cross off. 12 minus 8 is 4. That's the height. This is the radius. 64 times 4, let's see, is 240 and another 16. 256 pi. I think everything's in centimeters. So that'll be our volume. 256 pi centimeters cubed, or 89.4 cubic centimeters. All right. Not too bad. Pretty easy day today. Just a couple questions. And with that said, this is my first attempt at a remote brain break. The person in my place, hopefully nothing gets out of hand. I'd keep an eye on, well, obviously Mason Silver. Anyway, don't stand up yet. Wait and let's go through this. So the idea is you're going to move a piece of paper around your waist without grabbing it. You're going to carry it like a tray of dishes. You'll have your paper, you'll have your hand, and you're just going to hold it flat, hold that piece of paper out, and without holding on to it, okay? So there's you holding a piece of paper. So find a piece of paper and stand up. Don't stand up yet. Let's read through all this first so everybody understands. Put your right hand out and your palm up. Put the paper on top of your hand. Okay, we're not doing this yet. Just wait. We're reading it. I know you're excited, but just hold on. All right, so don't grab the paper as you're doing this. The paper has to stay on top of your hand, kind of like that waiter one we did with the notebook. Okay, keeping the paper level, at a level height, move it around your waist, and to transfer the paper to the other hand, you can only drop it. You can't grab it. Okay, so you can't grab the paper, so you're going to go around your waist, and then you're going to make a pass, and you're going to do that 3 times. Okay? So you're going to do this. That's one round when you go around once. And when you do it in the same direction, you're going to do it 3 times without trying to drop the paper. Next, after you do that, switch, and then go the opposite way, around your waist 3 times without dropping it. And the last part of this is to try to, let's see, what's this? Let's see, previous. Now I go forward. There we go. And the last thing to do is try to do this as fast as possible. All right. Everybody get out a piece of paper. And now, stand up. Keep it quiet. The person in my place is probably getting a little scared the way it is. So stand up and give it a go. You can use spiral notebooks, it says, so try that. So go 3 times around. This would be kind of cool with your eyes closed. Probably your eyes closed too if you can. Go 3 times around, keeping it level. Some of you are going pretty slow. Some of you are going pretty fast. Interesting. All right, now go the other way. 3 times. Without dropping the paper or grabbing the paper, try to keep it level. And once you're done, go ahead and have a seat. If you're not done by the time I finish, you will be done by the time I go on to the next problem. Okay? Like I said, I'd keep an eye on Mason Silver. All right. How'd it go? Go ahead and raise your hand if you were able to do this, and I want the person in my place to make tally marks on how many people actually did this. I just want to see how hard it is. You're the only class to give this one a go, so give it a shot. Okay? Thank you. And that was our brain break, paper twirling. That was a remote brain break. I'm not sure if I like this or not. I'll find out tomorrow whether it went well. And again, if there's any problems, please write them down and I'll address them tomorrow. Back to work. Next problem we're going to do is a person in a rowboat 2 miles from the nearest point on the straight shoreline. Wishes to reach a house 6 miles further down the shore. If the person can row at a rate of 3 miles per hour and walk at a rate of 5 miles per hour, find the least amount of time required to reach the house. It's asking for time. What is the least amount of time required to reach the house? I believe this is one of your examples, and here's the picture. The easy way out is just to calculate how much time it takes to go this way, and then from here all the way down, walking and rowing. The reason there's a picture is to help you understand that there are, again, a right triangle. You're trying to find the distance. You're going to probably divide it by the rate, and that gives you your time. Okay? So there's the picture. You're trying to minimize the distance. Could be more than one answer. And it's saying, don't forget, if you're this guy on the boat, maybe you want to go this far and then walk. What's the best way of getting there? How far down should you row versus how far should you walk? That's the whole idea. So in other words, what is the best point of entry to get there? What's the best place to go ashore and then go for a walk? And that's what we're going to try to do. And that's why you're here. You're here to try to get better at learning these things. All right? So, anyway, time equals distance divided by the rate. We've already talked about that. You have to find the best point to go ashore. I don't think it's at point B. That'd be ridiculous. So, 4 plus the x squared, where'd that come from divided by 3? Where the heck did that come from? Time. Distance divided by rate. Oh, the 3? That came from the rowing rate. The 5? That came from the walking rate. So, on this right triangle, this second one represents land, and this represents the water. Okay? Or the rowing and the walking. Rowing and walking. Okay? There's the two distances divided by rates. What's the x represent? Well, the x represents how far down you're going to this point. What is the best place, how far down to go from the perpendicular distance b? That's what x is. So you have your equation. We've used this one other time. And now give it a go. Take the derivative and set equals 0 and solve. Okay. I just rewrote it as a for power rule purposes. I didn't want to use the quotient rule. So I wrote it as a power rule. Remember, this will be to the 1/2 power. So I'll give you a minute to jot that down, find the derivative, and see what you got. All right. Let's get after it. Let's take the derivative. Remember, the domain is, it can't be bigger than 6 because that's how far it was away. It was 6 miles. Okay? So that's your domain from 0 to 6. It could be 0. That means if you're at 0, you end up at point B. If it was 6, that means you rowed the whole way and you never walked. Okay? So one represents walking the entire distance, one represents rowing the entire distance. So on a closed interval, there has to be a maximum, there has to be a minimum. The function is continuous for all values, and it's also differentiable for all values. Okay? So let's take the derivative. Take the 1/2, drop it down out in front, and then subtract 1. The second one's easy. I mean, 1/5 times -1. So that's not too bad. On this one, don't forget you got the chain rule. The derivative of the inside is at 2x. And the derivative of the outside is -1/2. And the 1/2 times the 1/3. Okay? So jot that down. and we'll solve it in just a minute. All right, set it equal to t, or I'm sorry, set it equal to 0, and we'll solve it. And this is your ability to solve equations. You can take the 1/5 over to the other side, do some cross multiplying, solve it that way. You can graph it out, see where it crosses the x-axis between 0 and 6. You have a lot of choices on how to solve this. But hopefully you realize that this will not yield any critical numbers. This will never equal 0. So that won't equal 0. So you don't have any critical numbers. So we're moving on. We're more concerned about the 1/3 and the -5. All right. So I rewrote it. Getting ready to cross multiply. You can do it like that. And now I can square both sides and solve it. Okay. I'm going the old route, cross multiplying. Some of you want the calculator route, that's fine. Before you square both sides, you have to isolate it, or you can square it, just include the 9. And now you're ready to solve. So here, on this step, I cross multiplied. On this step, I squared both sides. Okay, squared it. Getting pretty good with a mouse. All right, squared both sides. Good. Now distribute and solve. Okay, I'll go back. I heard somebody say go back. All right. Here we are. We're going to pick this up and we're going to solve it. Like I said, distribute. I'd probably get that. I'd divide and take the square root. Okay. So x equals 6/4, or 3/2. And that's the time. Or that's the x. Now you put back in here and solve for time. Remember, you can do 3/2, store x and type all that out. Or you can substitute it, end up with 1.733 hours. Okay? So that means if we go back to our original picture, sorry, you put 3/2 in, work it out, get 1.73 hours, or 1 hour and 44 minutes. That's how long it's going to take to go 6 miles rowing and walking. That means if you were at B on the picture, you went down 1.5 miles from your boat, you rowed that far, and then you walked the other 4.5 miles. Okay? So hopefully you got this solution, figured out your algebra. That's exactly what it means. You went went that far down on your point in your rowboat. And so you rowed to D. This is 1.5 right here. And this is 4.5 right here. And the whole trip, going that distance, is 1 hour and 44 minutes. 6 miles is pretty far, I guess. Okay. This is the f of A, f of B, f of C. Okay. This is f of A on a closed interval. So this is f of A right here. This is f of B right here. And this is f of C right here. Do you have to calculate all this? Absolutely not. But this is how to find the absolute minimum and the absolute maximum I talked about last week when you were doing your quiz. So you need to include f of A, f of B, f of C, and figure out exactly how long it is. And you can see that this is clearly the minimum amount of time. All right? That brings us to a close. I think, I don't know, you got about 10 minutes left. I'd use the 10 minutes to get started on these 4 problems. Tomorrow, I'll answer questions. Maybe I'll even do a 1 for 10 out of this section tomorrow, out of something from last week. Okay? So, answer questions tomorrow. Jot this down. The person in my place, if there's ever any problems, please let me know. Okay? Thank you, and have a great week break. I'm just trying to get the homework back up just a minute. There we go.